Hello everyone, welcome to numerical series of network theory. And the numerical problem is, in the network shown in the figure below, the switch is closed at t equal to 0. Determine I di by dt d square I upon dt square at t equal to 0 plus, and this is the RLC circuit where resistor 10 ohm, value of L 1 Henry and C 1 microfarad, value of V equal to 10 volt. So if switch K is closed at t equal to 0, then I0 plus equal to I0 minus equal to 0. Then we can redraw the circuit. Closed, switch closed. Then apply KVL in this circuit. And the KVL equation is V Ri plus L di by dt plus 1 by C integration of 0 to t I dt, it dt. This is equation 1. And then we can write the equation as Ri plus L di by dt plus 1 by C it equal to 10 and put t equal to 0 plus. Then R I 0 plus L di 0 plus dt plus 1 by C I 0 plus equal to 10. Therefore R into 0 plus, this value is 0, so R into 0 plus L di by dt plus 1 by C, and this value is also 0 equal to 10. Therefore L di I 0 plus dt equal to 10. The value of L is 1, already mentioned in the question. Di 0 plus upon dt equal to 10. So di 0 plus upon dt equal to 10 ampere per second. And differentiating equation 1. This is equation 1. We have to differentiate equation 1 with respect to 2. Sorry, with respect to t. Then R di dt plus L d square I upon dt square plus it upon C equal to 0. Put t equal to 0 plus, then R di 0 plus upon dt plus L d square I 0 upon dt square plus I 0 plus upon C equal to 0. Then this value we have already found 10, and the value of R already 10. Value of L equal to 1 already mentioned in the question, and we have to find this value. Upon this value is 0, so 0 by C is equal to 0. Then 10 into 10 plus d square I 0 plus dt square. Then d square, simplify this, we can get d square I 0 plus upon dt square equal to minus 100 ampere per second square.